Okay, so lesson 1.3, using midpoint and distance formulas. I will warn you that these formulas are formulas you will use over and over and over and over and over again, like this whole book. So you might put like a sticky note where it's kind of sticking out of your page and say midpoint on it. That way you know where it is, because you're going to use it over and over. So the midpoint of a segment is the point that divides the line. So if I were to draw a line here, and then we have point here, and one in the middle. These two are exactly the same length. So the midpoint is what divides a segment into two equal parts. It's the main thing you need to know. A segment bisector is a point, ray, line, or line segment that intersects the segment. So even though this is the midpoint, if I have a line going across here, that line is actually going to be called the segment bisector. So it's the two different ways to know your vocab. All right, let's look at example 1. Put this in your journals. All right, we have a picture of a skateboard here. In the skateboard design, you have segment VW. I'm going to highlight it here. VW, which bisects XY. So this is XY at point T. See how they have this labeled T? I know I kind of drew over top of it. And then XT, so this part of this segment, it tells us that that is 39.9 centimeters. Find what XY is. Okay, so we have a segment going like this. It's bisected. This is XT and then TY. And they want to know the distance from X all the way to Y. Okay, well, we know what this one is, right? 39.9. So does that mean we know what this one is?
39.9.
Correct, because they are the exact same measure. So to find the whole thing, I can say 39.9 plus 39.9 equals that XY that we're trying to get to. Right? So now just add those. What's 39.9 plus 39.9?
79.8.
79.8 what? Very good. And you were able to do all that because you knew that these were equal. Good. Example 2. Okay, this is V. This is M, and this is W. Okay, so it tells us point M is the midpoint of VW. And you can see they've marked it that we know it's the endpoint because the two segments on either side equal each other. We're supposed to find the length of VM. Well, they tell you VM equals 4x minus 1, and MW equals 3x plus 3. So, again, what do we know about these two segments? This segment compared to this segment, what do we know about those two? They're equal. Yeah, so if I were to do this, now can I solve for x? Yes. So I'm going to rewrite 4x minus 1 equals 3x plus 3. So now I got to just get all the x stuff on one side and all the other numbers on the other side. So I'm going to move this 3x. It's a positive 3x, so I'm going to subtract it. Combine like terms. So it cancels on the right. What's 4x minus 3x? There's only one x left. Rewrite. Now I need to move the 1, so I'm going to add. So then I get x equals 3 plus 1 is 4. So now I know what x equals. But what is it asking us to find the length of?
The length of the,
Yep, it wants us to find Vm. So I look up here at Vm, and that's the first equation. So I'm just going to take this 4 and plug it in where that x is. 4 times 4 minus 1. What's 4 times 4?
16.
You were giving me the answer already. So then the length of Vm equals 15. Cake, right? All right, so let's take a look at the midpoint formula. And you need to have this in your journal if you don't already. The biggest part of this that you need to have in your journal is right here. That's the actual formula. Whenever you're dealing with midpoint formulas, you're dealing with a coordinate plane. When I say coordinate plane, I'm talking about the graph plane like this over here. It's how you find the middle of 2 points. So whenever you think of a coordinate plane, how would I list a point on that plane? I would list it x, comma, y, right? So if I have 2 of these, I have this set, and I want to find out the middle, you're going to add this one plus this one and divide it by 2 to get the middle. So that's what you see here. We added the x's together and divided by 2 to get my x value for the midpoint, and then we add the y's together and divided by 2 to get the midpoint. So the biggest thing, if you do you have this in your journal already? Write midpoint formula and put this formula. You don't have to do the rest of it right this second. All right, so let's try some of these. This is example 3. And it says the endpoints of RS are 1, comma, negative 3. That's what R is. And the S is 4, comma, 2. Find the coordinates of the midpoint. So you don't have to graph it, but if you were to graph it and draw a line here, we're going to go over 1, down 3. There's 1 point. This is R. And the S is over 4, up 2. There's another point. So we're trying to find the middle point in this line right here. Now, again, you don't have to graph this to do it. I'm just giving you the visual. So we're going to use our formula, which remember is x1 plus x2 divided by 2. That's my x value. y1 plus y2 divided by 2 is your y value. So what are my x's here? This is x, y, x, y.
So 1 plus 4.
1 plus 4 divided by 2. So 4 plus 1 is 5 divided by 2. Just leave it as 5 halves. So there's your x value. So now what are your y's?
Negative 3 plus 2.
And then divide that by 2. So negative 3 plus 2 is a negative 1. So just leave it as a fraction, negative 1/2. That is the one nice thing about midpoints and coordinate planes. You can leave it as fractions. In fact, I prefer fractions over decimals, just for you to know. Okay, so the midpoint of RS would be 5 over 2, comma, negative 1/2. So, and if I were to actually graph that, it's going to show up right in here. Cool? All right, so let's do another one, the B. So we're finding the midpoint of JK. Oh, it tells you the midpoint. Or the midpoint of JK is 2, comma, 1. One of the endpoints, J, is 1, comma, 4. So we're trying to find what K is. K is X and Y. So this is an endpoint, and this is the midpoint. So we need to write our formula, and then we just plug in what we know. So if I write x1 plus x2 over 2, y1 plus y2 over 2. So what parts of that do we know? We can put 1x and 1y, right? So I could say 1 plus x, which we don't know, over 2. And then I could say 4 plus y, we don't know, over 2. But what do I do with this stuff? Or this one, the midpoint. That's the answer, right, to each of these problems? So I could say this whole section equals 2, because that's the x's, and this whole section equals 1, because that's the y's. And now I can solve, once I have an equation, I can solve for that missing x. So let's do the first one. We have 1 plus x over 2 equals 2. So to get x by itself, the first thing you need to do is get rid of this 2 on the bottom. If it is division, I do the opposite of that, which is multiplication. So I'm going to say 2 times all of that, 2 times all of that. That cancels. I have 1 plus x. And 2 times 2 is 4. Now to get the x by itself, I just subtract 1. So then I get x equals 4 minus 1, which is 3. So my first value for this k point is 3. Now I'm going to squeeze this y value up here because I'm out of room. So we have 4 plus y over 2 equals 1. And again, to move that 2, I just multiply the whole thing times 2 on both sides. That cancels. I'm left with 4 plus y equals 2 times 1 is 2. And then to get the y by itself, I just subtract that 4. So then your y equals, what's 2 minus 4? Negative 2. So then that gives you this second value over here would be negative 2. So now you've solved for k. Any questions on that one? Good. That's probably the trickiest thing you'll deal with midpoints, is getting an endpoint and a midpoint and finding the other endpoint. All right, the distance formula. You will hear this again and again. All right, so for the distance formula, again, think of a coordinate plane. And the distance formula is when you're trying to measure the distance on a diagonal. See how this triangle's on a diagonal here? For the vertical and the horizontal, you can just count 1, 2, 3, 4, 5, and that's how far the distance is. Or you could do the subtracting of the x's or the y's, depending on which one you're doing. But at an angle, you can't count that. So you use this nasty, ugly formula to find it. In order to do that, you need 2 points. So you see they have this point B and this point A, and you just plug those in to solve, and that will tell you how long that line is. And often it's a decimal or a fraction. Rarely is it like a whole number, just so you know. You're gonna get like 6.2. Okay? So let us practice one. Real quick, how they figured out how to solve this distance formula is from the Pythagorean theorem. I don't always know how to spell Pythagorean theorem, which when you're dealing with a triangle, a squared plus b squared equals c squared. A squared plus b squared equals c squared. So the distance formula is dealing with the c squared. Okay, that's all it is. If you notice here, if you take the square root to get rid of that 2, then you have the square root of a squared plus b squared equals c squared. That's how they made that formula. They just like write it out so you can memorize it better. So, example 4. What is the approximate length of RS? And here's my endpoints. Endpoint, the first R is 2, 3, and S is 4, negative 1. So do I have 2 points? Yes, so I can solve for RS. Equals, here's our formula, the square root of, let's practice writing it out, x2 minus x1 squared plus y2 minus y1 squared. Now, oh, they've made some adjustments, yay. Does it matter which of these points up here I make my 1s and my 2s? As far as x2, x1? No. As long as whichever one you make your ones, it's both of them. So like this is x1 and y1, and this is x2, y2. So as long as your 1s are on the same point and your 2s are on the same point, then it doesn't matter. So let's plug it in. We have the square root of 2 minus 4 squared plus 3 minus a negative 1 squared. And you see when I say minus a negative 1, I do a double parenthesis thing going on over here. I do that because when you have a negative next to a negative, what does that mean? It's a positive. So I do that, so I recognize that right away. All right, so the square root of, what is 2 minus 4?
Negative
2 squared. Plus, what is 3 plus 1? 4 squared. So negative 2 times negative 2 would be? Positive 4. Negative times a negative is a positive. And then 4 times 4 is?
No,
Yeah. And then you add those together. 16 plus 4 is? 20. So I have the square root of 20, which if I were to do on my calculator, I'm going to get a decimal like I warned you, 4.47. So this is the distance on this, for this segment is 4.4. It doesn't give me a measurement, so it's just units. Yep. Units is what you say when they don't tell you the measurement. So 4.47 units.
Oh, so you have to like round it
to 2 decimal. Oh, yeah, because it'll be longer than that. There is a way to simplify this square root. The square root of 20, it's a little ugly, but you can do it. And I'm not going to go over that today, but I'm just letting you know there is a way to make that a little prettier. But you can, for now, you just grab your calculator and do the square root of 20 and round it to 2 decimal places. Any questions on how to use either one of those? All right, you're doing 1 through 21 odd and 25 through 33 odds. So just the odds. Show your work, because I give points for showing your work.